Hello, everyone. My name is Jeff Onko, and this is my course project in which I'm going to focus on improving the way a support desk prioritizes incoming IT tickets. This is a pretty common issue. I've been in IT departments and various IT departments many, many years, and I'm sure that at some point in time you all have had to support a help ticket. So, pretty common issue. As per the project objectives, I'm going to try and cover some specific items here, specifically task analysis, user experience design, things like transparency, uncertainty, feedback loops, trust building mechanisms, especially. I also want to take into privacy and ethical considerations, as well as other topics that we covered in this third and final course here of the series. As we know, the way the current process is, we don't always capture what's actually in the full ticket description that we can, nor do we take that information and try to detect historical patterns using what's entered there. So the question, as I mentioned, is really whether a machine learning model could help produce more accurate, transparent, and context-aware recommendations. So what does those tasks break down into? And that's what this diagram shows. It's basically the task flow for just a general, very ambivalent ticket triage process. Basically, the requester enters the issue, fills it out with the required fields. Some of those fields help trigger the initial priority. Agent reviews the ticket, reads the description, and then often adjusts it before actually beginning the work. So where actually is the opportunity to augment it with a model? And here's where it matters. The current approach, as I mentioned, doesn't really use all the potential information. We want to do that. We want to take into account historical similarities, any struggles between dependencies, or any linkages, I should say, between the different types of tickets. They're all involving the checkout page, for example, of an order process. And then they also historically tend to struggle with figuring out new issue types and how to categorize them. That's where the model comes in. Take advantage of those richer inputs, suggest a priority, give a confidence score, and then explain why that decision was made. So who's all involved? We both have the usual suspects, requesters and agents. For requesters, the workflow stays simple. Submit the ticket, they see the assigned a priority, they get a short explanation or provide one, and then they get, after the submittal, an opportunity to review it with a this seems wrong type of link. For agents, once they get the new ticket, it shows a suggested priority from the model. It receives a confidence level from the model and a brief explanation. And then the agents can also accept or override the suggestion. And this is a key feature that we learned. We want to use that in order to be constantly providing feedback data, and that gets used for improving the model over time. Okay, so another mechanism is, of course, feedback loops and inputs. Very critical for human-centered AI. If a requester clicks, this seems wrong, that's a potential source, right? And they can fix that, what they perceive to be a misclassification. Agents can do the same, as I just mentioned. They can actually contribute that data in a very valuable way. As far as the inputs go, we want to make sure that we are only using in the model the non-sensitive inputs that we get, however. Things like the subject, trim description, the impact, urgency, and some of the other various types of the metadata from the ticket, to where it's staying in line with those non-sensitive inputs. We want to ensure that the transparency and privacy are adhered to. Otherwise, those will be displayed if we do not filter out those inputs and not use those in the model itself. Model choice and transparency. I selected a decision tree because it's fully transparent, easy to explain, and it handles the text-derived features and categorical aspects of the ticket. And it also naturally supports probability outputs. So if anybody asks why this priority, they'll be able to see based off of things like the features, right? Impact, urgency, and any keywords about outage or cannot get work done. This builds trust in the model, which is one of our key things in our design that we want to make sure that we have. On that uncertainty topic, to support we're taking this into consideration, it displays priority in the model's confidence. And you can see an example of that here. And I actually have an example of it here later once I get to the model. As I mentioned earlier, we intentionally exclude some of the sensitive or high-risk fields from the model itself. Names, email signatures, forwarded email chains, resolution notes, anything that could potentially be PII, can leak information that wasn't known at triage time, and that way we help avoid bias that way. And then we've also got the potential applicable laws that we want to take into account, GDPR and CCPA. So we want to make sure that we mask that personal information and only keep the non-sensitive fields needed for prioritization. Okay, so for the confusion matrix, you can see the results here of 6 attempts or 6 predictions. And this was basically using a very small synthetic data set. I mean, it was 20 rows of data, so the accuracy is going to be a bit off. But the important part, as dictated in a class, isn't necessarily the numbers, but that we're taking into account and we're making a point to measure performance. We want to know where the model struggles, and this is part of that baseline for transparency and trust with the users. Okay, so this is the decision tree visualization. This is part of the transparency process that we want to make sure that we maintain. You can follow the path from impact to urgency to category and see exactly how the model arrives at each recommendation. So impact, category, and urgency on down through these lower leaves down through here. Okay, for probability and outputs, this is where, again, it shows the actual confidence score on what it predicted. The interesting one here of note is example 4, right? And this is, again, these borderline cases are exactly where the confidence score becomes extremely valuable. The agent resolving the ticket would see this, and of course, the system would prompt them to double check the details and override the recommendation. And as I mentioned earlier, every time they override a low confidence prediction, then that is captured as feedback data, making things better. It becomes part of the training set and so forth, and it actually gets a better prioritization score. So in summary, this approach uses a model to enhance, not replace, a ticket triage process by improving transparency, taking into account richer inputs, and making sure we are maintaining strong privacy and ethical safeguards. The new system would support a more consistent and trustworthy process, keeping humans in control, not replacing them. So thank you.